Hello students, how are you? Can you guys see me? Hello guys, can you hear me? Guys, can you hear me? Am I audible to you guys? Please let me know through the chat box. Guys, am I audible to you? Please let me know through the chat box. Hello, anyone of the school? Hello students, can you hear me? My dear YouTube friends, you can also please do comment in the chat box if I am audible to you means. Please let me know whether I am audible or not. Yeah, so already some schools have been joined and YouTube is also going to. So let us start our discussion without wasting time. Okay. Yeah, thank you. Thank you. Right. Okay. So now, first of all, welcome you all. And I hope tomorrow we have exam, it seems. If there is exam, then there is no class. And if there is no exam, then there will be a class. So before that, advance Happy New Year to everyone. And I hope you all are doing well. And I think you guys have known that we got the exam schedule. Okay, so our exams are going to happen. And you know that February 28th is our chemistry exam. Is it true? Right. So chemistry exam is February 28th. So I feel that key rather than discussing about JEE main stuff and everything and all, we strictly focus on CBSE so that you guys can cover the topics. Okay. So now this is CBSE question. So how are the following alcohols prepared by the reaction of a suitable Grignard reagent on methanol? So the question is pretty simple that you are having a Grignard reagent. Okay, so that is treating with the methanol. Usually we know that Grignard reagent will be represented as RMGX. So let me take you some new page here so that it will very clear. So this is the end product, CH3, CH, CH3, CH2OH. This is the end product. So this is the product. Okay. So this has been treated. This has been treated with whom? So this has been treated with the methanol. Methanol is simply nothing but formaldehyde. So formaldehyde is a common name. So formaldehyde is a common name, but whereas the UPSC name is simply methanol. Okay. Okay. So this is methanol, right? So here, what Grignard reagent I am using? What Grignard reagent I am using so that my product should be this one. Okay. Pretty clear that. Okay, so to determine what is the reagent you are using, so we need to find what is the Grignard reagent. Just simple remember that whenever you are writing for the product, we already know that in Grignard reagent, you are going to get delta plus and Mg, sorry, here minus and here you are going to get the plus charge. Okay, so this will go, okay. So if you remember this one, this is going to add on the carbonyl carbon, add on the carbonyl carbon. If it is a aldehyde or if it is a ketone, whatever it may be, it is going to attack on the carbonyl carbon. So let's suppose we are taking that RC double bond OH and we are having R minus and Mg plus and hex. So now this R minus will attack here and this Mg plus will attack here because it will get partial negative charge and it will get partial positive. Now the intermediate step will be HCOMG X and here R will be there, and here H will be there. And further, if you are doing the hydrolysis, what will going to happen here? Here we are going to see MgX and OX will gone, and now the end product will become like this. What is the end product? HC bond OH H and R. So it is very clear that our RCH2OH. So the end product is RCH2OH. So let me clear you in the other page. So we are having a formaldehyde, okay, and we need to take a Grignard reagent, okay, and you are going to get a product as CH3 CH, CH3, CH2OH. So this is the product. So what is the question asking? They are asking about find out the Grignard reagent. So they are asking about the Grignard reagent. So now we have done that from the mechanism HC double bond O H, and we know that R delta minus Mg delta plus and X here. So this R minus is a nucleophile will attack on the carbonyl carbon, and MgX will attack on the carbon. So now the intermediate step will be RCO MgX. Okay, and here you are going to get R and H will be there. Further, upon doing hydrolysis, what is going to happen? Here you are going to release as MgX and OH, and here the H plus will go on oxygen and OH minus will go on MgOX. So now your end product will be HC, OH, H, and R. So pretty clear that R, CH2OH. So very simple. If you can see here that CH2OH is here and CH2OH here. The what will be the R will become? R is simply nothing but CH3, CH, CH3. So if you want to write RMGX, so RMGX is simply nothing but CH3, CH, Mg, X, and CH3. So this is our Grignard reagent. I hope you guys understand this one. If you are clear with this example, please let me know through the chat box. Please let me know through the chat box, guys. Guys, please let me know through the chat box. If you are clear with this, please let me know through the chat box. And next example is, again you have to treat with formaldehyde, and now you want to find the Grignard reagent. So now the product is like this. They have given the product like this, CH2OH. So this is the product they have given. And again, same story. This will be additional one you are going to get. This will be the additional one you have to going to get. Just simply remove this one and add H plus MgX here. So this is your Grignard reagent. Will become this one. Okay. Just replace CH2OH because in the reactant you are having one carbon. So this carbon is going to carbonyl carbon is going to convert it into alcohol, attached carbon. So that is why you have to break this chain and add MgX. So this is your Grignard reagent. I hope you all guys are understanding this one. Okay. Now next question is, you see this one. The next one is pretty simple that I'm going to give you. So usually these kind of questions you are going to get in your board examinations for sure. In your board examination, you are going to get. Okay. So now first one is LiAlH4. Why I am doing this one when we are having so many pages? Why we need to waste the page? Just see. C double bond O, C H2, C double bond O, O CH3. Can anyone tell me what is the group attached here? What is the group here? This is ester group. Okay, and here ketone group is there. Okay, remember, if I am treating with LiAlH4, what will be the product? And if I am treating with NaBH4, this is sodium borohydride, lithium aluminum hydride. And if I am treating with a reducing agent, H2 in the presence of palladium or platinum or nickel. Okay, if I am treating with this reagent, what will be the product? That is the ideal thing you people need to remember. Okay, now if you see, always remember LiAlH4 can reduce, LiAlH4 can reduce ketones, aldehydes, okay, aldehydes, acids, and its derivatives like esters, oil chlorides, like that anamata. Okay, but NaBH4 only reduces ketones and aldehydes, but not acid and its derivatives derivatives. Okay, but H2 here LiLH4 cannot reduce alkenes. Another very most important you people need to remember. LiLH4 cannot, will not reduce alkene. But this will reduce aldehyde, ketone, acid, okay, acid derivatives, and simultaneously alkenes and alkynes also, because NH2PD, or we can say that hydrogen in the presence of palladium is a very strong reducing agent, very strong reducing agent. So now the end products will be, become like this. So if I am treating with, NaBH4, it can only reduce ketones. So that's why your product will become what? Double bond. Ketone is there. Just replace the ketone with CH2OH. Or sorry, not CH2OH. I'm so sorry, guys. Just replace the ketone. Just replace the ketone with OH group. Okay, and as it is, it will be there. It will be as it is. It will be there. Okay, it will be as it is. Why? Can you take it as it is? Because it will not have the ability to reduce the ester. So this is ester group. So ester को ये reduce नहीं कर पाएगा. Let's suppose if I am taking LiAlH4, LiAlH4. So LiAlH4 if I am taking, then it can reduce ketones. Okay, and remember, whenever like this it has been given, just break it and give one H here, one H here, right? So then this will become what? CH2OH plus CH3OH. So here this will become CH3OH, and here it will become CH2OH. Okay, so this is the same for this one, or for the hydrogen palladium also, same product you are going to get. So very most important, very most important, that LiAlH4, or we simply say that LiAH is going to reduce everything except alkenes. It is going to reduce everything, whereas SBH, sodium borohydrate, except acids and its derivatives like esters, okay, oil chlorides, acid halides, and everything and all, okay, will not be reduced. Okay, but H2 palladium can reduce everything anamata. Okay now, right? So now we are going to talk about solubility. In the last class, sir discussed about solubility. Pretty simple, that solubility is depending upon the alkyl group which is attached to the alcohol. Okay, solubility depending upon the alkyl group. So let's suppose if I am having, okay, 1 2 3 4 4-membered alkyl group attached to the alcohol. 1 2 3, okay, 3-membered alkyl group attached to the alkyl present to the alcohol. Now among these two, which is more soluble? Obviously, which is having less number of carbons. Here we are having 4 carbons, here we are having 3 carbons. Where the less number of carbons is there the solubility will be higher. So simply we can say that solubility is inversely proportional to the number of carbons present in the chain. Okay, why? Because this is a hydrophobic part. What is this? This is a hydrophobic part, which is a water repellent, or we can say that which is a non-reactant. So jitna zyada non-reactant badega, the reactivity will be decreases. So that's why solubility ka case mein, if you see the solubility case, the solubility for this will be lower, because more number of carbons, less will be the solubility. Okay, very most important. Everyone has to remember this one. Okay, now. So I hope you all guys understand here. Okay. And another important thing, why they are soluble? Because they are having a ability to form a hydrogen bond with the water. So let's suppose if this is water, now what type of bond is forming here? Hydrogen bonding. So why alcohols are soluble in water? क्वेश्चन आपको बोर्ड में ऐसा पूछा जा सकता है कि sorry guys, this is English class, right? So why alcohols are soluble in water? Alcohols are soluble in water due to hydrogen bonding, that's it. Okay, so this is you people need to remember, amma. Okay na? Next topic, what is that? What is chemical reactions? Very most important, chemical reactions. Okay, directly from your exam only, from your NCRT only, I'm picking and I'm teaching now. Nothing too much worry about it. Let's suppose RCH2OH is there. Okay, let's suppose RCH2OH is there. Now, if you can clearly see, or we can also say that ROH, if I'm writing, whatever it may be, this is one type of alcohol. If we are breaking the OH bond, okay, if we are breaking oxygen and hydrogen bond, okay, at that time alcohol will act as nucleophile. Alcohol will act as like what? Nucleophile. Okay, if I am breaking the bond between carbon and oxygen, if I want to break the bond between carbon and oxygen, okay, we have to do what? We have to do protonation. We have to do protonation on the OH group. We have to do protonation on the group. In this situation, it will act as what? Electrophile. It will act as what? Electrophile. Okay, very most important, right? Protonated alcohols will act as electrophiles, and alcohols can also act as nucleophiles. So let's see with one example so that everyone can understand. ROH, and we know that oxygen will have a lone pair over it. Okay, now if I am treating with, let's suppose if I am having a carbocation, this is a carbocation, CH3 is there. So now this is my carbocation, and if this is my carbocation and we have a oxygen with a lone pair of electron, now oxygen will try to donate its lone pair to the carbon. Why? Because this is electron deficient, okay, and oxygen is having a lone pair which can readily donate to the carbon. What will going to happen here? When oxygen is donating, there is a bond formation will takes place. Okay, there is a bond formation will takes place, that is CH3 CH3. When oxygen is donated its lone pair, or we can say the lone pair is involved in the bond between oxygen and carbon, now you are going to generate what? Positive charge on the oxygen. So we know that positive charge on oxygen is what? Unstable. Positive charge on oxygen is unstable. So positive charge on oxygen is unstable. What will going to happen here? So whatever the shared pair of electrons here, this is lone pair of oxygen, amma. The shared pair of electrons, due to positive charge on oxygen, okay, so the shared pair of electrons between oxygen and hydrogen will be given to oxygen by removing H plus proton. Okay, very simple. So ये जो hydrogen है, hydrogen which is having lone pair, this will be given to the oxygen, and now hydrogen will go as H plus. Now what will be the final structure here then? The final structure I am writing here. The final structure, that is ROCH CH3 taken thrice. I hope you guys understand this one. And here the H plus will be remain like that. Okay, na? So this is what the breaking of oxygen and hydrogen bond. So when there is a break between oxygen and hydrogen bond, alcohol will act as what? Alcohol will act as a nucleophile. Alcohol will act as a nucleophile if there is a break between oxygen and hydrogen. Okay, now. So next, what will going to happen in this case? Let's suppose if I'm having an example, RCH2OH, and if I am doing a protonation, let's suppose HBr is there. Okay, so I'm writing H plus and Br minus. Now we know that this H plus will be protonated on the alcohol. So H plus will be protonated on alcohol group. Why? This is an electrophile and here electrons are having. So this electrophile will attack there. So what is the product you are going to get? Here you are going to get RCH2OH. And again, when the lone pair is given to this hydrogen, what is going to happen here? You are going to get a positive charge. You are going to get what? Positive charge on the oxygen. Same story. Okay. So whenever you are having a positive charge on oxygen, now always remember, if an oxygen with hydrogen and having a positive charge, try to remove as H2. How to remove as H2O? Now, in between the carbon and oxygen, there is a shared pair of electrons. So these shared pair of electrons will be taken by oxygen. Now, what will going to happen? RCH2 plus and plus these shared pair of electron taken. So now you are having H lone pair. So which is simply nothing but H2O here. Now this is a carbocation, right? Now this is a carbocation. Okay, so this is carbocation here. Yeah. So now this is a carbocation here, and we are having a nucleophile, that is Br minus. So very simple, RCH2 plus and Br minus will attack here, and the product will be RCH2Br. Okay. So this is what we are going to happen. Very simple. So in this situation, alcohol is acting as a what? Alcohol is protonated. This is actually protonated alcohol, not normal alcohol. This one, protonated alcohols acting as a electrophiles. Why? You can see here, there is a formation of electrophile here by just removing or releasing H2O. I hope you guys understand how there is a bond breaking and how there is a bond breaking between oxygen and hydrogen. They will act as a nucleophile. But next one is protonated alcohols. Protonated alcohols, while breaking carbon and oxygen bond, then they will act as a electrophiles. I hope you all guys understand this one. Okay, I hope you all guys understand this one. Next one is very most important, acidity of alcohols. Acidity of alcohols and phenols. Acidity of alcohols and phenols. Very most important. Okay, acidity of alcohols and phenols. So what is going to happen in case of acidity of alcohols and phenols? Let's suppose if I am taking RCH2OH and if I am treating with a metal like sodium. So we know that sodium is always releases one electron. Okay, now we know between oxygen and hydrogen, oxygen is more electronegative, hydrogen is electropositive. Now this hydrogen, what will going to happen? RCH2O minus and Na plus will going to take place, and this H plus will consume this one electron. Okay, and it will become what? H2 gas. Okay, so always remember, whenever we are treating with a metal, there is a gas is going to release, that is H2 gas. As we are having only one hydrogen, so that's why half H2 plus you are going to get RCH2ONa, which we are going to call it as sodium alkoxide. What is this? Sodium alkoxide. Sodium alkoxide is the product. Okay, so just to simplify, okay, so in alcohols alcohols, or we can also say phenols. They are ready to lose. They are ready to lose H plus. So if they are ready to lose H plus ions, we can clearly say that alcohols are acting as what? Acids. Alcohols can act as acids. So whether alcohols or phenols, they act as acid. Why? Because they are ready to lose H plus ions. Okay now. So another best example, if I am taking about 2 moles of a phenol, if I am taking about 2 moles of a phenol. If I am taking about 2 moles of a phenol, so 2 moles of sodium, what will going to happen here? So that is 2Na will become 2Na plus 2 electrons. So here you are having how many hydrogens? 2 hydrogens. So what will going to happen? H2 gas will be released here. Now what is the ion you are going to get here? Here you are going to get sodium phenoxide ion. What you are going to get here? This is sodium phenoxide ion you are going to get. Phenoxide ion you are going to get. Okay. So sodium phenoxide you are going to get here. Okay. Now, so now the interesting fact from here is alcohols also losing H plus and phenols also losing H plus. Now among these two, which is more acidic? Now question will ask in your examination, which is more acidic, alcohol or a phenol? Alcohol or phenol, which is more acidic? So to tackle this question, we need to see 3 important parameters, which is simply nothing but polarity. Okay, what is that? Polarity. Let's suppose if I am writing here RCH2OH, and here we are having a phenyl group. Now we can see here, this is sp3 carbon and this is sp2 carbon. Okay, so this is sp3 carbon and this is sp2 carbon. And we already know that, what we know that, so this is less polar, and this is more polar. Why it is less polar and why it is more polar? Because of sp2 carbon, it will have more electronegativity, then they will pull the electrons from oxygen, which leads to decrease in electron cloud on oxygen. सिंपल सी बात है, यहाँ पर ऑक्सीजन है, यहाँ अल्कोहल है, इन दोनों के बीच में, so the bond between oxygen and hydrogen is weak. The bond between oxygen and hydrogen is weak. What will going to happen? H can easily remove. H can easily go. If the bond between oxygen and hydrogen is strong, H plus will not go easily. So now, how to determine this bond strength? How to weaken the bond strength? So our main agenda is to weaken the bond strength. So how we can weaken that one? So here, if you see, this is sp2 carbon. If you in the phenol, if you see, so this is sp2 carbon. So this sp2 carbon, what will going to happen? It is more electronegative. It will try to pull the electrons to this side, which is eventually weakens the bond between oxygen and hydrogen. Okay, when there is a weakened, so this can easily remove H plus ion. But whereas in sp3, it is having poor polar, or we can say that less polar. You can say it can release H plus, but not readily as compared to the what we going to call it as phenol. Next, another example, if you can see, you can also see that ionization of alcohol also. Ionization of alcohol, simply nothing but RCH2OH. So if we are doing ionization, you are having a equilibrium constant Ka. We can also say ionization constant, that is RCH2O minus plus H plus. Next one, ionization of phenols. If you see, ionization of phenols. In ionization of phenols means ionizing. You are making them into ions. Okay, so that is phenol. If you take, what will going to happen in case of this one? Here, O minus plus H plus. O minus and H plus will be the answer here. So O minus and H plus will be going to happen here. Now we can clearly say that this is Ka2, okay, and this is phenoxide ion CH2O minus. This is alkoxide ion, and this is what? Phenoxide ion. We know that here the charge on oxygen is localized. Charge on oxygen is what? Localized. What is the meaning of localized? Means it will remains there only. Okay, when there is charge is localized means the charge will be present there only, it will not move. But whereas here, there we can clearly observe delocalization of charge is going to take place on oxygen. So how the delocalization is taking place? Because of resonance of phenoxide ion, because of resonance of the phenoxide ion. You can see this is a phenoxide ion. These phenoxide ions will undergo resonance, which will make the compound more stable. Sir, how, sir, can you draw the resonating structures? Yes, you just see here very clearly. So you can clearly say here, this is called phenoxide ion. So these phenoxide ions, always remember, now I am going to write the resonance structure. So SN number 1, 2, and 3. Remember, now the double bond is between 2 and 3. Okay. And between 1 and 2, what is there? Nothing is there. So now what we have to do? We have to shift the lone pair between 1 and 2. That is double bond shifted between 1 and 2. And 3 should get what? Negative charge. 3 should get what? Negative charge. So this negative charge will be shifted on the carbon 3. So now what is the resonating structure here? So then the resonating structure will become double bond O. This double bond shifted here, and others will remain as it is. Next, this will shift here, and this double bond will be shifting here. I am writing another resonating structure. How this one? And here double bond O will be common. This is shifting here. You're getting double bond here, and this double bond will be remain same. And this double bond shift here, you are going to get negative charge on the carbon. And again, if you shift this negative charge here and double bond on this carbon, what will going to happen here? Double bond O, and here you are getting negative charge, and here you are getting double bond, and here you are getting double bond. Next, this negative charge will be shift here, and this negative charge will be shift here. And finally, you are going to have, sorry, this will be not there. Finally, what you are going to have here, finally, we are going to write the resonating structure. So that is O minus, and this will be double bond shifting will take place. Now, how many resonating structures are there? How many resonating? 1, 2, 3, 4, 5. So due to 5 resonating structure, phenoxide ion will be more stable. And we can also say negative charge is present. Negative charge is present at ortho and para position. Okay, so that is why if we are having minus I or minus M groups on ortho and para groups, they will increase what? Acidic strength. They will increase acidic strength. Very, very most important. Okay, so why phenols are more acidic than alcohols? 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 Due to delocalization of phenoxide ion. Okay, so the conjugate base of phenol will be more stable, we can also write due to the resonance. Okay, right. And we can also say that alcohols are less polar. Phenols are more polar, and we can also say it is having a weak ionization. And it is having what? strong ionization. It is having a weak ionization and it is having a strong ionization. I hope you guys are understand this one. Okay. I hope you guys are understand this one. Okay. Yeah. So next, moving forward, we will give some examples. Let's suppose this is, I want to give you all acidic strength. Acidic strength. So acidic strength is directly proportional to minus I group and inversely proportional to plus I groups, directly proportional to stability of carbocation, stability of, sorry, carbocation I am telling, conjugate base, stability of conjugate base. Okay, sir, what is this conjugate base? Very simple. Let's suppose if you are having an alcohol here. So whenever if you are dissociating, you are going to get RO minus plus H plus. So here this is acid and this is base. So this base is simply nothing but called as what? Conjugate base. So stability of the conjugate base and minus I group plus I group is inversely minus I is directly proportional, plus I is inversely proportional. And another one thing, you can also write more electronegative atom or electron withdrawing groups. So if any electron withdrawing groups is also present, then they will also show more acidic strength. So now let me show you one of the example here. Let me show you one of the example. CH3OH, CH3, CH, CH3OH. Next one, CH3, 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 OH. So we can see here, we already know CH3, all the alkyl groups are plus I groups. All the alkyl groups are plus I groups, or we can also say electron donating groups. They are also electron donating groups. So this is plus I group, 1 plus I group, here 1, 2 plus I groups, 3 plus I groups. More the plus I groups, what is the acidic strength? Acidic strength is inversely proportional to plus I groups. More the plus I groups, less will be the acidic strength. So this will be more acidic than this. Very, very most important. Very, very most important. If you see plus I groups, they will reduce the, what they will reduce? They will reduce the acidic strength. Now let's suppose if I'm having F CH2OH, okay, Cl CH2OH, Br CH2OH, next I CH2OH. If I am asking you, this is A, B, C, D. If I am asking you to find the acidic strength, if I am asking you to find the acidic strength, and what you know, acidic strength is directly proportional to more electronegative. So among these, which is more electronegative? Fluorine, chlorine, bromine, and iodine. Now, what is the order of acidic strength then? Order of acidic strength is pretty simple. That is F CH2OH. Okay, then that is simply I can write as A is greater than, B is greater than, C is greater than D. I hope you all guys understand this one. And here, fluorine, chlorine, these all are minus I groups, or we can also call it as electron withdrawing groups. Is it clear to you all? Okay. Is it clear, guys? Please let me know through the chat box. Is it clear to you? Okay, JNV Gondia, JNV Vardha, and other schools. Is it clear to you? Right. So next, yeah. So now, very, very most important examples I'm going to give. Find the acidic strength. Okay. So this is phenol. This is paramethyl phenol. Okay. Okay. Right. So A, B, C, D. Find the acidic strength of these phenols. Inka acidic strength find karo. So to determine the acidic strength, what you have to do, you have to know what are plus I groups or minus I groups. Here hydrogen is present, so neutral, there is nothing will be there. CH3 is a plus I group. Okay. and NO2 is minus I group and minus M group also. And OCH3 is minus I, but here this is also plus M group. So due to the domination of minus I plus M, they will ready to donate the electrons, which will decreases, or we can say the electron cloud between them will become increases. So we can clearly say from this one, okay, first C because of minus I group, and then we can say that A, then B, then D. Last will be D because of the what we can say that plus some group here. Okay, I hope you guys understand this one. This is the acidic strength. Very, very most important. Acidic strength is directly proportional to minus I and inversely proportional to plus I. Okay, now. So here plus M group means what? Plus M group means which can readily donate. Here you can see this oxygen can donate and can form a double bond here. So which can increases the इलेक्ट्रॉन डेंसिटी ओवर द ऑक्सीजन एंड हाइड्रोजन. यहाँ पर इलेक्ट्रॉन डेंसिटी और बढ़ा देगा और हाइड्रोजन विल बी more attached to the oxygen, which cannot lose H plus very easily. So that's why D is the poorest acid because OCH3 is a plus M groups, which will increases the what you say that electron density on oxygen, so that hydrogen will be more close to the oxygen. It will not move away. Okay. Yeah, so that's about the acidic strength of that one. And the next one, if I'm talking about, right, this is the acidic strength order. Next, last one, esterification. Esterification. Esterification, always remember in esterification, let's suppose if I'm taking a phenol, okay, plus if I'm taking an acid, usually esterification can be done between alcohols plus acids or acidic derivatives Okay, so now here we can see that plus H O C double bond O CH3. This is an acid here. Now we can clearly say from this one, in alcohols, always remember, alcohols always give H plus. Okay, but here they will give OH minus and here H plus. Both will remove as what? H2O. So what will be the product here? O C double bond O CH3. So which is nothing but RO C double bond O R, which is ester group. Okay, so this is will be formed by esterification. Okay, I hope you all guys understand this one. So the base can be, they can be used as pyridine, pyridine they can use. Okay, they will use as a base. Okay, so this is another most important. Last one, very, very most important for our examination. That is, let's suppose ROH plus C double bond O R, and if I'm using pyridine, okay, pyridine if I'm using, which is a strong base, which will help to neutralize HCl, because here you are having Cl and this both will go as HCl and the end product will become what? End product ROC double bond O R plus HCl. Okay, so this pyridine will help in the progressive reaction. Pyridine will help in the progressive reaction and to neutralize HCl. So always remember, from alcohol, what we have to take? From alcohol, only we have to give H plus. From others, we can take anything. Next one, preparation of aspirin. Aspirin preparation you can see. So this is salicylic acid. We all know this is what? Salicylic acid. What is this? Okay, this is salicylic acid. Okay, and the next one is what? Next one, you people know, this is very clearly C double bond OH. Okay, O C double bond O CH3. So this is what? Acetyl salicylic acid. Acetyl salicylic acid, which we can also call it as aspirin. Acetyl salicylic acid, or we can also call it as aspirin. So now we can clearly say from this one how they are going to prepare. Let's suppose COOH, here O and H plus, if I am taking an acetic anhydride. Acetic anhydride means what? CH3, C double bond O, O, C double bond O, CH3. Okay, from here, simple, nothing you have to do. You have to just remove CH3 COOH. Okay, you have to remove just CH3 COOH. Let's suppose if I am removing this one. Okay, so here you are going to get CH3 COO minus. Okay, and just attach this one with this, and you are going to form a acetyl salicylic acid. Okay, break that one. Okay, and just make a bond between this one. Okay, now so ISCO, not this one. You have to attach this one, because here from here hydrogen will be gone as H plus, and you are getting minus here, and this will be go as here you are getting positive charge, and this positive charge will attach here. So which eventually you are going to get a this type of structure. This is minus and this is plus, so which you are going to call it as acetyl salicylic acid, and shortcut we are going to call it as aspirin. So preparation of aspirin will be done between what? That is salicylic acid plus acetic anhydride. Acetic anhydride will help in the formation of aspirin. Okay. So how the aspirin will be prepared? Aspirin will be prepared by acetic anhydride. So this is called acetic anhydride under the presence of salicylic acid. I hope you all guys understand this one. Okay. So 4:35. Thank you guys. Thanks for joining the class. We will see you tomorrow. Okay. Bye everyone.